Hi, salam sejahtera. We are from Group 3 and today we're going to present about our hydrologic group project. First, I would like to introduce our group member. First is FENG, second one is QUAN, the third one is FARIS, the fourth one is Go Junhong, and the last one is me, Tan Mu Sien. For introductions, urban water quality is becoming more difficult to manage because of changes in rainfall patterns and water flow. Rain is the main source of water. Too much rain can cause floods, while too little can lead to drought. Malaysia receives high rainfall each year, so the government encourages rainwater harvesting to reduce flooding and save water. This effort supports the National Water Conservation Policy and follows the updated 9 Malaysian Plan. Accurate rainfall data such as how often it rains, how long it lasts, and how intense it is plays an important role in planning drainage systems. Stream gouging is used to measure the flow of water in rivers. It can be done using direct or indirect methods depending on the size and the speed of the river. The location for our group project is at Temerloh, center of Pahang, at the meeting point of the Pahang and Semantan rivers. The rainfall station that we chosen is Lupo Pasu, Sungai Pahang, Pelkra Paya Laman, Lancang, and Kuala Krau. And the water level station is Sungai Semantan at Jabatan Kereta Api, Mentakap. For the district info, the population was about 160,000 people at 2020, and the areas was about 2,250 kilometers square. The major town is Mentakap, which is 10 to 15 minutes away.
Next, for methodology, we use Google Earth Pro for this project. Google Earth Pro is free mapping tool. It's help view river, watershed and terrain clearly. You can analyze rainfall areas, you can draw catchment area. It's easy to use for basic GIS tasks in Next is rainfall and water level location. The data was chosen using the ID Malaysia, which is Department of Irrigation and Drainage. Our data comes from 3 locations, which is first is Lubuk Pasu in Sungai Pahang, Fekra Paya Laman in Lancang, and the last is Kuala Krau. The water level data is from Sungai Pahang in Temerloh town. This area is part of the longest river in Peninsular Malaysia, which is Sungai Pahang. Next, the method of calculation. First is arithmetic mean method. It's calculate average rainfall by adding all values by dividing by number of station. The formula is P equals to Pi divided by N. Method is Thiessen polygon method. The Thiessen polygon method is weights rainfall from each gauge based on area. For the first step is establish straight line between every precipitation station. Next, create bisector of the connection lines that are perpendicular to each other. Then use this bisector to build polygon. Calculate the polygon area, and the last step is formulate the average precipitation. For the last method is Hasso-Hatel method. This method estimate average rainfall by drawing lines connecting areas with equal rainfall. For the step in this method is first, collect rainfall data. Next, plot data on map, draw Hasso-Hat, divide the areas, calculate the mean rainfall, and the last one is compute total average.
Dr. My name is Xiaofeng, and I will present the data presentation. So first, we get the rainfall data from the website, and then we make a table. So after finding the data, we found the highest rainfall event for each station, which is from 11th October to 16th October. After finding the highest rainfall event, we use the formula to calculate the discharge for each rainfall water station. So these 3 graphs are the hydrograph for each station. And after finding the hydrograph for highest rainfall event in each 3 station, we use the straight line method to separate the base flow and the upper flow. So after use the straight line method to separate the base flow, we use the formula to find the UH ordinates, and then we make a graph for each 3 station.
And now I'm going to present about terrain profiles and gradient slope between stations. And I'm using Google Earth Pro to draw the path between the station to calculate the gradient slope between stations. So we have 3 rainfall station and 1 water level station that I will explain later. So for the first path, from the station Felka Paya Laman to station Kuala Krau, this station has a length of 27,300 meters and an average slope of 5.9% and negative 7.1%. For the second path, from station Kuala Krau to station Sungai Pahang, and this both station is also rainfall station, and the length of this path is 30,500 meters and an average slope of 4.5% and a negative 4.6%. For the third path, from station Sungai Pahang, which is the rainfall station, to station Sungai Semantan, act as the water level station, and it functions as a guideline for us to determine the water level in the river nearby. And the length for this station is 10,400 meters and the average slope of 6.1% and negative 5.9%. For the cross-section of the river at Sungai Semantan di Jambatan Kereta Api Mentakap, we have determined the cross-section 1, which is the upstream, cross-section 2, which is the middle stream, and cross-section 3, which is the downstream, to clearly identify where is the direction of the water flow. So the length from the upstream to the downstream is 32,200 meters, and this data will be used to calculate the peak flow. So this is the elevation level for the cross-section 1, 2, and 3. I will explain the detail in the equation later. And this is the elevation level along the river, which is uneven because of the length, and the catchment area between station, which is 351 km square, that we calculate using the Google Earth Pro. And now we will show the correlation of the peak flow of our river using rational method. And the formula is Q equal to 0.278 CIA, where C is the coefficient that we have assumed as 0.5 from the standard MSMA second edition, I is rainfall intensity, and A is catchment area that we have calculated just now. For the first one, we have calculated the 3 days, which is from the 12th to 14th October, as the peak rainfall of all time that have least in the data presentation. So we take these 3 days and divide by 3 to get the average of 101.5 mm, and divide by 72 hours, which is 3 days, to get the rainfall intensity. And we just substitute into the equation to get 68.8 m cube per s. So this is quite abnormal. So we use the standard rainfall intensity in the SMA second edition to calculate. So we have got 4,878.9 m cube per s, which is normal. For the Manning's equation, Q is equal to 1 over n multiplied by A multiplied by R power of 2 over 3 and S power of 1 over 2. And n is the coefficient that we have also assumed as 0.035 from the standard SMA second edition. And A is the cross-section area width and depth from the elevation level that we have shown just now. And R is equal to A over P, and P is equal to W plus AD. The slope of the river that we assume as 0.01 is shown in the Google Earth Pro. So for the cross-section one, we just substitute the data into the equation, and we have got 9,177.9 m cube per s. And the cross-section 2, which is 11,070.1 m cube per s, and the last one is 11,890.5 m cube per s, and I will explain why later. Now we are going to explain two methods that we use to calculate the peak flow of our river. So basically, for the rational method is used to calculate how much rainwater would flow into the river, while the Manning's equation was used to estimate the actual capacity of river to carry the floodwater. So we have used the rational method to calculate the 3 days of our peak flow, but it gives a very small discharge, which is very low and not suitable. So we have used the standard of 100 mm per hour rainfall intensity, which is more realistic and give a normal peak flow. For the Manning's equation, we have calculated the discharge were increased from the upstream to downstream. This is because the accumulate of the water and is give a peak discharge in the downstream. So by comparing the both method, we have known that Manning's equation has a 2 to 3 times higher than the rational method. This is expected because the Manning's equation shows the actual of the river, the water river can carry.
Next, analysis and results. We have used three methods to estimate the rainfall. The first one is arithmetic mean method, and the second one is decent polygon method, and the third one, isolated methods. The arithmetic mean method gave an average rainfall of 127.87 millimeter by simply averaging the rainfall from all stations. This assumed rainfall is evenly spread across the catchment. The decent polygon method gave a slightly higher value of 130.30 millimeter. This method divides the catchment into areas around each rain gauge, giving more weight to stations covering largest area. And for the isolated methods, gave the highest value, which is 191.90 millimeters. It is the most detailed method because it used rainfall contour lines, which is isolates, and calculates weight rainfall between them, showing how rainfall actually varies across the catchment. This difference shows that the rainfall was not evenly distributed. The isolated method is more accurate, especially for flood or runoff studies, because it reflects real rainfall variations. However, the arithmetic mean is suitable for quick estimations, and the decent method offers better accuracy than a simple average.
Good morning lecture. So now I'm going to talk about discussion and conclusion. So in this study, we explored how rainfall impacts river behavior in Temerloh Pahang, which is crucial for flood management in high rainfall Malaysia. We analyzed that rainfall data from 3 stations, finding that Manning's equation was the most accurate than the rational method for estimating peak river flow. And the river flow discharge increases on downstream. Among rainfall estimation methods, the isolated method proved that most precise for verifying rainfall distributions, which improving our ability to predict floods. In conclusion, understanding rainfall, catchment area, catchment features, and appropriate hydrological methods is key for effective flood risk management and better drainage system design. So I think that's all from our group. Thank you and have a nice day.